second example. This one, find the molecular partition function in which the molecule's energy levels are equally spaced, i.e. where E0 is equal to 0, E1 is E naught, E2 is 2 E naught, E3 would be 3 E naught, etc. E naught being the constant energy separation of all the levels. Key here is it asks for the molecular partition function, which we've been representing as Z1, one for just a molecule in this case. And your book and many books will represent it as a lowercase z. And lots of books will also use lowercase q for it, so be aware of those. But remember, Z1 is just the sum over all of molecular energy levels of this Boltzmann factor. Beta, of course, is our usual 1 over kBt. And the only thing is that now we know what the energy levels are. They're n times E naught, where n is 0, 1, 2, 3, etc. So I just write them out. I write out each term in this. So n equals 1 to n equal infinity in principle. So it's e to the minus beta E0 plus e to the minus beta E1 plus e to the minus beta E2 and so on. Then I plug in what each one of those are. E0 is 0, E1 is just E naught, E2 is 2 E naught, E3 is 3 E naught, and so forth. And the very first one is special because it's 0, and the numerator and the exponent of the exponential, and anything to the 0 power is just 1. And then I look at this piece here, and sort of a standard trick that we'll see again here in a lecture or so, is I can take this infinite sum here and factor out the very first term. So I factor out e to the minus beta E naught, and that leaves 1 for this term. I factored out one of these, so that just leaves me minus beta the E naught. I factored out one of these, so that leaves me with e to the minus beta 2 E naught, and so on. And then I just noticed that, well, this was Z1 up here, and that's the same series as I have here. So this whole sum in parentheses with this e to the minus beta E naught pulled out is just Z1. So now I've got something that I can then solve for Z1. I have Z1 on this side is equal to 1 plus e to the minus beta E naught times this sum here, which is also Z1. Solve for Z1, so I just simply take the second term here, move it over to the left side, factor out a Z1, and then finally divide by the factor, and I get then that the molecular partition function in this case is expressed very simply as just 1 over 1 minus e to the minus beta E naught, where E naught is the separation, energy separation between all these equally spaced levels.